Here's a video on sensible and latent heat. This is probably the most important thing that you will learn from HVAC is that without sensible and latent heat, and more important, latent heat of the two, how it works is what makes air conditioning possible. Here we have a pot of water. It doesn't matter the volume or the temperature that it originally started at. What the thermometer shows you is that pot and the burner below is at 207 degrees. That's not the water temperature, that's for the pot and the burner below. The water temperature will change and rise with more heat. We all know that. But at 212 degrees, water changes state. It goes from water to steam. And why latent heat is so important. For that to happen, it needs a huge amount of heat. You keep throwing BTUs at this heat. The water will not change its temperature. It will stay at 212. And this video actually shows it at 195 because the gun is not able to take the internal water temperature as much as it's taking the surroundings of the water. But what you'll see is as the water temperature rises to the 212 stage, or on this video 195, you hit that latent heat spot, and so that water stays there. It keeps absorbing heat but is in a constant mode of changing state, going to steam, and until the water all boils off into steam, it will stay at that spot, being able to absorb and absorb and absorb. The water is now 94 degrees, 207 the pot and burner. Now the burner is almost 300 degrees and the water is 100. And of course the water temperature is rising. Sensible heat increases. It keeps changing and changing and changing. Its surrounding is changing. Now the burner is almost 400 degrees. The water has moved up to 114, 116, 117. The water will continue to go up in temperature until it hits latent heat. Again, this is still sensible. Latent heat is where the point where the water changes to steam, and the water cannot get hotter than the 212, because when it gets hotter than 212, it automatically changes to steam. As long as the heat of the water keeps rising, it is sensible heat. It's at 148, 152, 154, 156. That is sensible heat because it's changing. Now it's this next video. This is now 500 degrees or more. The water is 195. The temperature gun might not be accurate, so it's actually 212 degrees if you're at sea level, but this is latent heat, which means the heat will not, of the water will not continue to rise In this place, it's going to stay at whatever that temperature was. On this thermometer, it's 195. If you had a thermometer sitting in the water, it would show 211 and a half, 212, somewhere in there. But it will not go up. Even though the pot is now 500 degrees instead of the 200 we saw earlier, the pot temperature keeps going up because metal temperature will continue to rise. It will, until it melts, it will continue to rise, which is, depending on stainless steel, is about 12, 13, 1400 degrees. I don't know that off the top of my head, but it's up there quite a ways. So the pot's going to stay rising in temperature, and the water will stay at what they say is a steady 195 degrees on the thermometer, but it should be, the water would be about 212 if you had a thermometer actually in the water. So where's all the heat energy going? It's going up in air. It's turning to steam. Steam gets hotter than 212 degrees. But there it is, 195. It stays there even though the pot is getting hotter and hotter and hotter. The water stays at the same temperature because now it's latent heat. Now, at this point, the important part of latent heat is that that pot is absorbing heat and using. This is where air conditioning comes in. The evaporative coil that the air from your home blows through, that's inside your garage, your attic, or in a closet, or it could be outside in a package unit, that evap coil gets the refrigerant boils off around 40 degrees. Yes, refrigerant boils at 40 degrees. So it stays at 40 degrees and it keeps accepting more and more and more heat until that liquid refrigerant turns into a vapor and the latent heat is over with. But as long as it's a refrigerant in a liquid form, the latent heat will stay at that one spot continually for a long period of time until, and when I say long period of time, it's just moments, but it's got to keep moving, and that's why a compressor keeps pumping that liquid refrigerant through that evap coil, because it keeps that latent heat running at a certain temperature, constantly cooling the air coming through the home.